Create a scatter plot. Are we gonna plot all of them? Can we do it? Let's plot all of them. Yeah, let's plot all of them. Okay, so there is a concept here. After you plot these points, it will still look like a line that can cut right through it. It might be a little bulky here and there, but you can kind of imagine that there's going to be a it seems like it's increasing. You can tell it drops down a little bit, from year 9 to 10. Oh yeah, I just noticed that, but it's okay. Okay, now is that all they want? Yeah, let's plot them. Create a scatter plot. Okay, check. All right, let's do. Okay, I'm gonna guess that you're likely to come up with an equation that go through them eventually, but not yet. So let's do another one. Use a table, create a scattered plot. Why there's so many, dude? Wait, how many points are we doing? All of them?
Yeah, I guess all of them.
Okay, all right. 4, 12, 5, 10. 5, 10, 7, 7. So this one is decreasing. You could kind of tell.
Yeah.
So this is real life, likely. Okay, they probably got these statistics from somewhere. No, I could be wrong, or they could just make it up. But they're trying to mimic, at least if it's not real, it's mimicking the real statistic that you can find somewhere. And normally it would look something like this, and it's related to the concept of linear. So it's decreasing, like you can imagine there's a line going through it. And if you, let's keep plotting. And is that all?
Yeah.
Yeah, okay. All right, that's it. And what likely you will learn next is that you'll come up with what they call its best fit. Or look at this, best fit line, which is going to be a line that kind of cut through them neatly. That represents a straight line. So it's just like a model that predicts what's going to happen, in the future. So imagine that. Let's see. Okay, the data points on the scattered plot below shows the amount of natural snow received and the amount of artificial snow made by jet ski resort for each of 24 weeks. Okay, draw. Here we go. I think we could attempt to do this without having to come up with there's a way to do this perfectly, by the way. What you do is that there's a calculator and there's even like an app, Desmos. I don't know if you've ever seen that, Desmos. You put in this bunch of coordinates and they'll spit out like the best fit line that can go through all of them. So this one, I believe you're going to attempt to be an artist and just guess it. Draw a line of best fit for these data points. It doesn't have to be exact. Okay, so what you're going to do is that, something like that. I would do like one end to the other. Yeah, that looks good. Watch, it's just going to be just fine. That looks good. So this is like real life. It's about you're predicting what's going to happen approximately in the future. Imagine that, So it's like going down as time passes or whatever the X unit is. And this one, same thing. Let's do it. Make a guess of a nice line that can cut through them. So it's like a model that the lines is going to predict. Imagine that for a particular scenario. All right, same thing. So it's decreasing. You could also keep in mind that the line that you've been, sketching happens to be decreasing as time passes for this one, hours. Okay, so there you go. Okay, good. All right, now I believe they gave you the actual line, and let's see. I'm jumping to the A right now. A, for these 21 dog sitters, as experience increases, okay, the amount of charge tends to. So you could look at like the label for the X and the label for the Y axis. So it's describing as the experience increases. It means that, it goes up like 1, 2, 3, 4, 5. You see right there on the bottom. As you move from 1 to 13, what happens to your amount? which is the y, it's also increases. So let's select increases. Is that okay? Could you see that? Yeah, the way it's trying to describe. So it's yes, increases. Okay, now for B, same scenario. There are blank. Okay, so it should be positive correlation. That's because it's increasing. Is that okay?
Yeah.
And using the best fit, we would predict a dog sitter with 9 years of experience would charge approximately what? So you can kind of look at nine, look at nine, and look at the line. Don't look at the point. Okay, try to look at the line instead. But if the point is there, it's fine. So what do you think? 9 comma, it looks like about 16 or so. I don't know. 9. Let's see what they give you. What are the options at 9 years? 16 something. To me is 16.3. I'll take that. Could you see it like on the line there? Yeah,
Yeah.
16. I think, yeah, something like that. Yeah, looks good to me. All right, there we go. Okay, I think the same type of selected choices you're going to be having to go for. Okay, the same idea, but it's now decreasing. So let's go to A right away. So but read carefully too. Sometimes they're trying to trick you. It says as weight. So the X, basically the X increases. The fuel efficient is your Y. So you can see there, it's decreasing. So that's you okay if you go X increases, your Y decreases. Okay, good. 24. There is a negative correlation. Okay, yeah, okay. When it's flat line, there's no correlation. Is that okay? If you see a flat line, but this one is negative correlation. Now use the best fit to predict again. Just look at the line. You don't have to worry about those X or the points. At 3,500 pounds, kind of look at 3,500 pounds, like between 3,000 and 4,000 there. What is your approximate Y? It looks about, I don't know, 27, 20 something. I'll let you look at it. So it's a little small for me, but I think that looks good to me.
I think
27.
27.
Is it 27, 30? Yeah, let's go for it. Yeah. All right. So this is more like application that you're doing for a linear, y mx plus b, by the way. I think we're going to have to come up with one by looking at the graph, but we'll see. Okay, same idea, I think. Theater revenue increases, like the X increases. Your rental increases. Yeah. Okay, and then this one will be positive correlation because it's going up. Again, using the best fit, we're going to predict at 60 million. So it's the units in million on the x-axis. So 60, it's about what, between 10 and 12, I think. So 11, I think. You can look at it carefully for me because they're too small for me. It's okay.
Yeah, I think it's like
Okay,
11.4.
looks good. Yeah. All right. And very good. Okay, here we go. I think we're about to deal with the actual equation. You see that? Y is fancy because this is real life instead of like nice, numbers, fraction and all that. But now it's still approximate, by the way, that 1.87. If it's real life, it's like probably like 1.87943, whatever. But they rounded to two decimal places. You can see the both values there. The M and the B, MX plus B. You see that? Okay, let's see. Do we have to calculate? Oh, yeah, my screen went off. Do we have to calculate? Let me double check. Sorry, 1 second. All right. For an increase of 1 hour in time worked, what is the prediction? What is the predicted increase in the amount of money spent? So basically, it has to do with the slope, but that means for A, okay, yeah, we can actually do the math here. Let me double check, okay, for 1 hour increase. Okay, so Now you see that m equals 1.87. Now, if you wonder about how that can be written as rise and run, it's the same thing as this. Okay, so therefore
Yeah.
the denominator has to do with your x. So as you move one over, your y is this much. So therefore the answer is going to be 1.87. You'll get used to it. So yeah, for A, it'll be 1.87. And I want to double check it now. Yeah, it looks about 1.87. Okay, we'll see. B, what is, and I'll elaborate on that. B, what is the predicted amount of money spent on entertainment for a student who work any doesn't work any hours? Okay, so what that means is when the hours is zero, you see the line there? It looks
Yeah.
about, actually, we can do math. I think they want you to do math. So if you want to predict, it's about between 10 and 15. Imagine it's cut through the y-axis. You see that? So we can do
Yeah.
math. Guess what? If you plug in x being zero in the equation, you see that y equals 1.87 x plus, you plug it in and calculate, 1.87 times 0 is 0. So you're left with 11.26. Could you imagine that? Yeah, imagine you plug in 0 for x. So the answer is 11.26. So basically it's your y-intercept or your b, your b value in y equals mx plus b. Okay, there you go. Now I think we're gonna use a calculator here. So I'll show you the work. So it says predicted amount when a student works 8 hours. So here we go. Let me put it in the calculator. So imagine you doing this, okay? But you can watch me do it. So I'm gonna do 1.87 times. I'll parenthesize it times 8. So 8 is the x. X is the hours. So it's 8 hours plus 11.26. Let me double check. Okay, that's it. So here's the answer. But yeah, go for 2 decimal places here. Okay, so it's 26.56. Is that okay? Imagine you use the calculator and plug it in. So that's it. Let's check it. Pretty sure. Oh, that means the slope. It's just the slope. Let me look carefully. I think it's A that it's missing, or unless we had in the value wrong. 26.56, 1.87 times 8 plus, yeah, it looks fine. Okay, let me see for A. For an increase in 1 hour, okay, in time worked, what is the predicted increase in amount of money spent? So it's basically your, oh, I see. They're talking about 1 hour in the equation. So you have to plug in 1. I thought they were talking about the slope. It's too small for me. See the 1 here? I'm going to plug in 1. Let me double check. For an increase of 1 hour yeah, it looks like as 1 hour in time worked. What is the predicted increase in the amount of money spent? No, for 1 hour. So it's not the equation. Increase in 1 hour, predict increase in amount spent. So the slope looks fine to me. Let me see, 1 hour.
See?
Okay. Could you zoom
Wait,
in a little bit? Yeah,
on
yeah.
your calculator for the 11.26, you only
Oh,
put 11
oh,
point
wow.
six.
Thank you. So that means A is right. Just the
Yeah.
last one, right? The last one.
Yeah.
Thank you. The key is a bit small for me, but let me bring it back. 2626, not 6. Is that right? Right there.
Yeah.
There you go. Okay, so it's 22. So it's the last one. So A is right. Is the last one. Be 0.22. All right. Looks good to me. Okay, there you go. All right. Okay, same idea. It's about time spent studying, and then you get your scores, the midterm scores. Is that okay? So let's see. Hey, think about that too. Seems to be like at least kind of realistic. You spend more time, your scores tend to go up. You see that? Yeah, this
Yeah.
is real. Yeah, seem to be real life. I don't know whether this is literal actual study they got from somewhere statistically. I don't know that. Yeah, if normally they actually got the real one, they would actually give you a, what do you call it, the source somewhere, maybe on the screen. But who knows? This is ALEKS stuff that they try to minimize the amount of thing that you can see on the screen. So it's like a week too cluttered. But anyway, what is the predicted midterm score for a student who doesn't spend any time studying? So this time is go right to the equation. The equation is going to be the y. So that means if x is 0, you plug in x, your y will be left with 15.68. Is that okay? You see that? If you imagine you do the calculation, 3.83 times 0 is 0. Therefore, you're left with just 15.68. So that's A. Okay, B. So if they say something like this, you could go ahead and use the slope value. So as an increase in 1 hour of time spending, that means it's you can see it's 3.83 over 1, and the denominator is going to be the 1 hour. So therefore, the answer is going to be 3.83. Is that okay? If you see something that talk about it increasing in one, what is and what is to predict the increase in the other is going to be the slope
Okay.
for the x, and then for the x and the y. Okay, what is the we'll use the calculator again for 12 hours. So I'll plug in for the y. So it'll be 3.83 times 12. Let me double check my input. Plus 15.68. See, look, when I press it, I don't look at it. So I miss 5 again. I missed a digit again. 568. Okay, there you go. So it should be 61.64. And that would be the score, yeah. So it's like, yeah, that's pretty good. Okay, now it's about time spent texting. instead of studying, you spend time texting, right? That means the time spent exercising. Okay, at least it's not about score. Exercising goes down. It makes sense. If you don't do your activities, you just text. That means your exercising goes down. Imagine you pausing and you just text. You pause instead of actually. Let's say you're in the gym, you pause. Therefore, the hours. Imagine you're trying to time your actual activities on a treadmill or whatever. You know what I mean? Imagine that. So yeah, it makes sense. Okay, so they gave you the stats. They give you, and they also gave you the line that predict that best fit, that y equals negative 0.74x. That is the model, they call it, right? The best fit model that predict this particular scenario. So that's that's real life stuff here. Okay, let's do it. A, what is the predicted time spent exercising for who doesn't spend any time texting? That means it's just going to be 8, like the beginning value is 8.64, okay, hours. Yeah, so what that means is that you spend all the time, you don't text, you spend all the time exercising. There you go. What is the predicted time spent exercising 4 hours? So we're going to plug it in. So here we go. Let me put in. Oh, let me explain. If you use a calculator, if you use the thing on the side, you see that icon there, right? You could, you don't have to worry. It will work. But I'll do it. But yeah, you can also use that if you don't have the calculator with you and all that. So here we go. It'll be, what is that? 4 hours plus 8.64. Imagine you doing this, okay? So it's 5.68 hours exercising. Yeah, double check. Yeah, looks good. And same idea. If texting, you increases 1 hour, therefore the y will be decreasing. You see the negative that describes as decreasing. Is that okay? If you wonder about what word they're gonna use, if there's a negative, your x still go increasing, by 1, but your y will decrease by 0.74. Is that okay? So
Yeah.
don't put the negative. Just put in because they already describe it for you. The word decrease, so you just put in the value 0.74. I hope that's okay. Yeah. There you go. Nice. All right. I think you're about to also do another one, but let me see. Let's look at the details on top here. The scatter plot shows the average monthly temperature X and the family's monthly heating cost Y. Okay, for 28 different months. And I guess those are the months that are the X's, I assume. Yeah, I think there are 23 different months. Okay, use the scattered plot to answer the parts below. All right, note that you can use the graphing tool to help you approximate the line. So you could do it right now if you want. Like draw a line that seems to cut through all of it. That looks about right to me. Yeah, it looks good. I don't forget this is going to be more of a approximate. See, because it says right there, write an approximate equation. So we're going to actually write that equation. We'll see. Let me see. Use the equation. I see. So we're going to do an equation here. So what we're going to do is that, if you don't mind, if you zoom in a little bit, we're going to actually tweak this one to make it easy. Do you know how? Okay. I'd like you to redraw or erase the line, but go through 100. You see, look, since this is about approximation, we could be smart about it. What we're going to do is that we're going to make a line that's easy for you to come up with the equation. So imagine you cut through 100 there. Yeah, try to get perfectly 100. Then kind of go through maybe 80. Wait, pick the one that, yeah, let me see. Does that look good to you? If you do that, it will be done much faster, and I'll show it to you how. Yeah, if you pick like nice number, like see 80 and 100, like the y-intercept and the x-intercept. Is that okay? Yeah, try it. Yeah, try it again. So 100 for the y-intercept and maybe 80 or 90. It's up to you. It doesn't matter because it's going to give you, it's about approximation. But don't go in between them if you don't have to. There you go. Watch this. How does that work? Let me show it to you. This is something that you can learn too. It's about the concept that I'm actually applying here is called x and y intercept. It's like you're going to use the x and y intercept and come up with the equation. So watch. You already know how to do it. You know why? Let me show it to you. Let me prove it to you. But first, we're going to come up with the m. We'll look at it. And then we're going to use this one. Watch. We're going to put the m in here once we figured it out. X and plus b, but plus 100. Remember why? Because we got the y-intercept.
Yeah.
See that? So we don't have to use that point slope. You can still do it, but you got to come up with 2 points on that line. So in this case, you don't have to, because we actually did a y-intercept, but we still gonna have to do the m. Is that okay? But think about it, okay? This is like the fastest way because we chose a nice number for the b value, which is the y-intercept. Remember, y equals mx plus b. That's what we're being. You were learning the process of which one to choose. You want to choose this one because you want to use this equation because you could make it 0 comma some number, which is 0 comma 100 in this case. So here we go. So we're doing this. So that's why the 100 is your b. Now, how do you do the m? Easy. I'm going to choose the point that you just chose. Let me write it out here first. The first one is 0 comma 100. The intercept, the y-intercept. But don't worry about the name of it. But we chose them nicely. And the other point, I'm using one end to the other. The other point will be 90 comma 0. You see what I did there? This will be your x1, y1. I know it's y-intercept, but we're using it as something else. It doesn't matter. Then your x2, y2. Do you get it? Because you know for sure it's on the line. You see that? Look at it, okay? The point that touched the y axis is 0 comma 100, and the point that touches the x axis is 90 comma 0. See that? Now we can calculate like you've been doing. Wait, before I do, you okay? You see how I come up with them, right? You okay? So now we can use the formula, the y1 minus y2. So here we go. Y1 is 100 minus 0, y2, and then x1, which is 0, minus x2, 90. See it? Easy.
Yeah.
So what we got is going to be 100 over negative 90, but we'll clean that up. Negative 90. So here, let me bring it down here. I know it's like kind of cluttered up there. So let me redo this. So if I divide the top and the bottom, I'm gonna give the negative in the middle. Like I'm gonna bring the negative in the middle of the fraction. Same thing. A positive divided by a negative is still a negative number, a negative fraction. So I'm gonna divide the top and the bottom by 10. So you're left with 10 over 9. Is that okay? That's it. Now,
Yeah.
10 over 9. Let me punch in the calculator. And you don't have to worry if you get a bunch of weird decimal. We're gonna write it two decimal places, just like the other ones that I've been doing. So, oh yeah, I can show it to you in the calculator. It's a negative, by the way. Okay, you know that. So I'll do 10
Yeah.
divided by 9. So okay, so it's 1.11. So it's negative 1.11 approximately. So here we go. Negative 1.11. Oops. So this will be your m. So here's your final form of the equation right there. 1.11. So let's put the equation in there. That will be your A. Is that okay? Your slope, yeah, 1.11. Let me see, double check my M. Yeah, 1.11. Rounding to two decimal places, just like the other problems they were, showing us. So we go with that. 1.11 for the M. X plus 100. Are you okay? You think you okay?
Yeah, I'm good.
I mean, we could have just punched this in the calculator. It's still going to give you negative 1.11 anyway.
Yeah.
Okay, now we're going to use that and plug in 35. The 35, if you notice on the x-axis, you see it's the unit for the x-axis. Therefore, it's going to be 35 in the x variable. So we're going to plug in x as 35. So here we go. Y equals 1.11. And then I'll punch in the calculator. 35, because they ask you to use 35 and then predict the monthly cost, which is the y, 100. So I'll punch this in. Yeah. Let me know if it's something confusing. Okay. So we'll do 1.11. We round it to 1.11 times 35 plus 100. And here it is. So we're going to do 138.85. 138.85 for B. Let me try to get rid of that bunch of decimal. I don't know. Maybe 4. Let me see if I can. Sure. Yeah, that thing. Anyway, all right, let's check. I'm pretty sure that looks good because you're free to do. This could be a little different entirely. The equation could look different, but the answer B tend to be close to about that much. Okay, it could be 140, it could be whatever, but it looks good. You'll have to accept it. Oh. Oh, you forgot the negative. Your fault there. Yeah, the one. No, I mean
Wait.
the one. Right, the slope is negative. Right? Yeah, because it's
Yeah.
going down. Yeah, that's it. Are you okay? Think about it, okay? Because if it's going down, it'll be. Oh, is there incorrect? Or B? Let me see B. Let me double check. Oh, I didn't put the negative. I myself did not use the calculator with the negative, so not just you. So here we go. But we're gonna choose every value the same. Is that okay? Yeah. Sorry.
Yeah.
Okay, right there. So it's 61. I mean, I should have made sense of it by looking at the graph. So it's going to be 61.15. Pretty sure now. But are you okay? Yeah. See how I use the numbers, right? Is that okay? Yeah. 1.5.
Yeah.
Yeah. Should be fine now. How many tries are we allowed to have? I don't know. There you go. See. Yeah. Just be neat. Yeah. There's a lot going on. There's a lot going on. I forgot to put the negative there. I think the same idea. I think. Right. Everything
Yeah.
the same. All right. Let's go ahead and pick your intercept. I would do 8 again. Let's draw the line through 8, the y-intercept at 8, and then we'll see how far you can go with the. Yeah, I would do that and then go all the way. Let's see that line on the back right around there. Is that 20? Do you see it? Kind of see if it's going to touch the 20 on the other end. Or you can, however you think that you can get a nice number out of it. But what I would look at the point that touched the frame at the back, all the way in the back there. Okay, imagine, or yeah, however you like. But go to the grid. Let me see. Like try to cross the grid. Does that look good okay to
Here?
you? Let me see if I can show it to you. Let me see here. Like this, okay? Imagine this. When you do the next point, imagine you, but this is an approximate here. When you have the line, imagine it's here. Try to go through the grid. Like the grid looks like this. See, there's a grid that, like the crosshair. Try to go
Yeah.
through the crosshair. One of them, where you see the line that crosshair like that. It will be the easiest to choose.
So like
Is that good?
here?
Yeah, that looks good, right? What is that? 18 comma 22. I'll make note of that.
Yeah.
Is that right? Yeah, I'll make a note. 18 comma. Why? Because we're gonna do like x1 y1. You know what I mean? Yeah, it looks good. Okay. Yeah, we'll take that. Yeah, it looks good. Really good actually. It probably look better than the last one. Right? We're gonna come up with the equation again. So we are gonna do y equals mx plus b again because we got the b being 8. Because don't forget though, it can only work if and only if you chose it to be the y-intercept. Nice. No, it could be a decimal, but we don't know how to approximate like between 8 and 10 or no. So what we're gonna choose 8. Is that okay? We don't know if it's gonna 6 and 8. We don't want to go between them because we don't know what the values are. But technically, if you approximate, it's still accepted. If it's close enough to, there's a bunch of variable answer that the computer will accept because they already programmed it to work. But the b that we chose is going to be 0 comma 8. The y-intercept will be 8. So, and then we'll solve for the m. So here we go again. We're going to do something. Y equals m. We'll solve for m. And this time it'll be positive because it's going up. Is that okay? Yeah. Plus 8. And the m we are about to do. But the coordinates are 0 comma 8, which is now we're going to tweak that into x1, y1. And the x2, y2 will be, let me see here. I'll look at the graph again. So we show, what is that again? X2, Y2, 18, no, 22 comma, we're going to do X first, right? 22 comma 18, is that right?
Yeah.
Okay, there we go. And then let's plug it in, the M formula, Y1 minus Y2, which is 8 minus 18. And then X1 minus X2, 0 minus 22. Is that okay?
Yeah.
Remember doing that? Okay. So this will be negative 10 on top over negative 22. Negative, negative become positive. So if we reduce this a little bit, we'll punch in a calculator. But getting that practice of actually reducing. If you have to write it exact answer, but this one is a word problem, so we're going to use a calculator. So let's see, approximately 5 divided by 11. So it's going to be 0.45 positive. So the m will be 0.45. So we're going to plug that here. So 0.45 to make it nice. Is that okay? So there's your equation. 0.45x plus 8. Or yeah, plus 8. Okay. And then we're going to use that by plugging in 18 for x. For the b, this is the a. So we're going to do y equals 0.45 times 18 plus 8. Okay. Let's see. 0.45 times 18 plus 8. So it's going to be 16.1. 16.1. And it looks about right. I'm looking now at 18. 16.1 for the x. Okay, we're looking at the x. When x is 18, it looks like the y is about 16.1. Yeah, based on our line that we come up with, the best fit line that we chose to draw. Yeah, looks good. Let's all right. See, they have like they computerize that to have like free range of answers. You know, everyone will have it a little bit different, but it's close enough to each other. The answers or the graph that you guys may be doing. Oh yeah. Okay, same thing, right? Yeah. Let's do it again. Choose the y-intercept to be, I don't know. You can even do 10, maybe 20. The y-intercept. Let's see. Try it out and see what we can come up with. 10 or 20. But try to get in like through those x's as much as you can. Now, I think that may not work in this case. Do you know why? Let me explain. They want you to go through those points like right in the middle, like kind of like cross through it, you know? Okay, right there looks good. Yeah, somewhere right there. But what about the crosshair? Is that 100 comma something or something something? Or come in a little bit. It doesn't matter. Okay, that's too far out. You know why? Because it's touching like the bottom of all the x's, like the bottom of it. Imagine it's slanted. Try to go through a bunch of x's. Okay, right there looks good, but go through yeah, that's fine. I think crosshair. What is the crosshair of that? 100 comma 80. Is that okay? Yeah, 100. Is that okay? 100 comma 80. Is that okay? I mean
Yeah.
80 comma 100. X comma Y. Yeah, go for it. 80 comma 100. Is that okay? Okay, so we'll use those values. Okay, same thing again. We're gonna do y equals mx plus b, and the b we got is gonna be from 0 comma 10. The b and the x1 y1. So it'll be 0 comma 10, x2 y2. It'll be 80 comma 100. Okay, so we do m. M is gonna be y1 minus y2, 100 minus 100, 10 minus 100, and then x1 minus x2, 80, like that. That means you get, and it's increasing, so you're going to get two negatives here. So they cancel each other out. So it'll be negative 90 over negative 80, which is going to be positive 9 over 8 in the calculator. Let's see, approximately 8 divided by 9. 9 divided by 8. Keep saying everything flip-flop. So it's going to be, I'll round it to two decimal places. It'll be 1.13. Can you see that? Is that okay?
Yeah.
So the m will be 1.13. Okay. So here we go. Rewriting it. It'll be m equals 1.13. It's positive because it's increasing. X plus B. B is your 10.
Lo puedo cancelar, pero también va a ir Alejandra con su sobrina, con su hija.
It's okay. Okay. It's okay.
Sí,
So 1.13x plus 10.
So
Sí,
it's
sí, sí. Sí. Órale.
Okay. And then we're going to use that by plugging in x with 50.
Sí.
Yeah.
Algo diferente.
Plus 10. Okay, let's see. So 1.13
Okay. Oye, y
times
¿qué te iba a
50
decir?
plus 10.
Oye,
So we
para no
got
olvidar.
66.5. Is that okay? 66.5.
Yeah.
¿No va? Okay.
66.5.
Yeah. All right.
Entonces, ¿con quién?
Very good. Okay. All right. I guess we don't have to worry about these ones now. Oops. What's happening? Done. Okay. Anyway. Okay. Consider this line y equals negative 2/5 x minus 7. What is the slope of a perpendicular line? What do you think? So there's the slope of the new line that is perpendicular to that one.
Would it be Like positive 5. Like
Yes, 5 what? 5.
what's it called? It's like
5 over?
5/2. Yeah.
Yes, 5/2 or 5 halves. Is that okay?
Yeah.
Yeah, 5/2. Yeah, and it's positive because we want the opposite, the sign, or they call it negative reciprocal. Negative on top of a negative become a positive. That's good. Okay, and then the slope of parallel line. What do you think? To that line, to that y equation.
Would it be negative 2/5?
Yes, exact same slope. Yes, exact same slope as the original. Very good. Yeah, for sure. Okay, same idea, but you'll have to manipulate it to get it right. There's an equation. There's a formula that can give you the slope just the way it looks right there. But I believe you have not been taught that, so you have to solve for y. All that. So I'll show you here. I know you know how to do it, but watch me do it again, okay? But I think you know it. So you're gonna try to solve for y equals mx plus b. Imagine you're gonna manipulate so that you get y equals mx plus b to identify the m. You know what I mean? So we have to go with that and manipulate it.
Yeah.
So, all right, we'll subtract both sides by 5x. I mean, I can do a faster way, but this is the way that I think you'll be best to look at and recognize it. So I subtract both sides by 5x, squeeze the 5x in front of the 6,
Yeah.
like that, and then divide everything by -3. I'll clean it up because it looks good. Sometimes you get a weird fraction back here, but this one is just going to be positive 5/3 x. So you can squeeze the x out to the side now. Yeah, if it's multiplying the numerator, it's the same thing as x over 1 like this, but we'll squeeze it out to the side. Not on the bottom, not in the denominator. -2. So this is the new, well, it's the same equation, but you can identify the slope, parallel, and perpendicular to it. So what do you think about it? A new one being perpendicular to this one.
So it would be negative 3/5.
Yes, very good. Now, I just want to point out, when I manipulate this original into this right here, they're the same equation. Is that okay? Think about it, okay? It's the same equation. It's in another form, different form. Exact same graph, exact same equation in a different form. Yeah. This is the standard form, they call it, the STD, and then this is the slope-intercept form. But anyway, yeah. And what about the perpendicular one?
So
Oh,
the
sorry. Parallel. The first one is perpendicular. It's correct, yeah. And the parallel slope?
5/3.
Yes, 5/3. Yeah. Okay. Next one. Okay, you got 3 lines, imagine, but they're all written differently. And they want you to do what? Let's see. For each pair of lines, I don't know which pair yet, but determine whether they're parallel. Oh, I see. They're giving you the choices on the bottom there. Between line 1 and line 2, are they parallel, perpendicular, or neither? You okay? So we're gonna test it out. So best thing to do is find all the slope first of each one. The first one is fine, so L1. L1 is still the same, so I'll just keep it. I'm gonna check my work, okay? Then I'm gonna manipulate L2, line 2, so that I get my slope. This one is easy. Watch, I'm gonna mentally do it. I'll bet you're okay. So I'm gonna divide everything by -4. So it will turn into -3/4. I know the denominator is -4, but remember, if it's divided by negative, the whole thing is negative. So x -7/4. Now, why is it minus? Because, yeah, it's a plus negative, so it's -7/4. Are you okay about it being minus? If I to divide by -4, it turned into a -7/4. Do you see it? Or no? What do you think about why is it a negative here? Just for algebra's sake? When I divide everything by -4. Do you know why? Have a look. This is something you must half down because you have to deal with like messy algebra later on, right? So you divide everything by -4, right? And you know that we have to do that like this and like this. Is that okay? Do you see it like the way I'm doing it? But I did it mentally here. But what happened is that right here, a +7 divided by a -4, it's a negative fraction. So it's a -7/4. But the way you could write plus negative, but it's more standard if you just write -7/4. Does that make sense?
Yeah.
Yeah, learn to, like see it quickly so it's that you can, speed things up. So that's line 2, line 3. So line 3, I'll do the whole work here. So I'll do it on the side here. So 6x minus 8y equals -6. Now, there's more advanced way to deal with this. You divide everything by 2 because you can to make it smaller first. You don't have to. You could go ahead and divide everything, to bring it over and then divide by 8, -8, or whatever. But I'll do this so you can see different ways to deal with it. You don't have to do it this way. You can do it the way that you understand, but it'll be the same. But watch me do this. It's something you may want to consider doing. So anyway, if I do this, I'll get 3x minus 4y equals -3. Why did I do this? Because it becomes smaller. You see, like the original becomes smaller to deal with. Then I subtract both sides by 3x. Then I'll left with -4y equals -3x minus 3. Are you okay with this so far?
Yeah.
Then I'll get my y by itself, dividing everything by -4. So I get y, and this become a positive 3/4. Is that okay?
Yeah.
And the last one here, it's a plus. So it's plus 3/4. So anyway, here's your line 3. Y equals 3/4, positive 3/4, plus 3/4 x plus 3/4 for the y-intercept. We don't care for the back here anyway.
Yeah.
Okay, let's answer the question now. So line 1 and 2, we're looking at this 2 here. Are there parallel, perpendicular, or neither? Based on the slopes that you look at, that you can see here.
So I think for lines 1 and 2,
Mm-hmm.
it's neither.
Yes. Is that okay? Just because they're flip-flop of each other, they're not opposite. Is that okay? Yeah, so it's neither. And what about line 1 and 3?
I think it's perpendicular.
Yes. Yes, very good. You okay?
Yeah.
I keep both facing the equal sign. I hope it's not messy here. Okay, and then what about 2 and 3?
That's neither.
Yep. Yeah. As you can see, you probably can't guess this, right? It'll be bad. Yeah, the combination to be perfectly right. So you have to do some math to figure it out. Okay, good. Very good. Okay, so they gave you one line. Find the equation of the line that is parallel to this line, the one that, above right there, and pass through that point. What do you think about that? So we're gonna do a parallel line to that one. That means the m will be the same, right? Okay. That
Yeah.
means this is very popular question, by the way. They give you a line. They want you to come up with an equation that goes through a point, but it being parallel. So you always want to use this here. It's easiest to use because it could answer pretty much 99% of the question out there. Okay, so it's point slope you want to use. So the 6, 4 should be x1, y1. Is that okay? So we're gonna plug it in, and the m, since it's parallel, that means it's just gonna be the same. Is that okay? And we're gonna do it again for the second find, the first find, the second find, same way. But we're gonna use this twice. But 1, here we go. 4 for y1. M will be the same because it's parallel. We're doing the first one. Is that okay?
Yeah.
And then parenthesis x minus x1, which is gonna be 6. And it says equation of a line. Believe it or not, you could probably punch this in if you want, but let's go ahead and make it look like y at x plus b for x minus 24. And then 4 minus 4, add both sides by 4. Tell me if you're okay with it. So it'll be negative 20. Is that okay? So this should be the first one. Double check my math if you're okay. 24, add 4 to both sides. Yeah, that looks good. So that's your first parallel line, the first equation. This is parallel and this is perpendicular. You're about to do. Parallel symbol looks like that in geometry. Perpendicular looks like that in geometry. So we're going to do, 20 minus 20, right? Negative 24. Okay, then we'll do this again. Y minus y1, same y, x1, y1, by the way. So it'll be 4. But the m, what is the m this time? Minus x1, which is 6. The m for it to be perpendicular.
Is it negative 1/4?
Yes. So I use that and then I distribute. Become a plus negative 1/4. Negative 1/4 times negative 6 is a positive. It'd be 6 over 4, but we're going to reduce that to 3 halves. You follow so far? Is 3 halves. Then y minus 4 so far. Okay?
Yeah.
And then add both sides by 4. So y equals negative 1/4 x. But then you can do your math on the side here, plus 4. How many denominator is 2? So times 2 times 2. So you're left with 3 plus 8 on top, all over 2. So 3 plus 8 on top, it'll be 11 over 2. So here's your perpendicular equation. Negative 1/4 x plus 11 y. Yeah, y equals negative 1/4 x plus 11 halves. Okay. You get all that? Okay. Yeah.
Yeah.
Okay, next one. Okay. Same idea. Do you think you can do this? I want to ask you. Do you think you can try to do this on your own by writing? But you have to actually make, because I want to look ahead, like 2021. I want to look ahead right away. I want to see if there's anything new, because this one is similar to the last one, but you kind of have to manipulate this to get y equals mx plus b first. You know what I mean? Think you can do it?
Yeah.
But then you have to go through, flip-flopping and make them opposite and all that, right? To get your
Yeah.
parallel will be the same. Careful, they switch them now. This time the parallel is the second one. And then don't forget the negative 6 comma negative 6. It'll be your x1, y1. Is that okay? You're gonna use, again, sorry, you're gonna make it look like this first, but then you'll use the point slope. You're okay with this one too?
Yeah.
To construct the equation. Yeah, you're gonna go here in the end mainly, and then make it look like this again on the bottom there. Okay, I think you can do this one, but can I see 20? Let me have a look at 20, and then you'll come back and finish that one. Okay, 20. Okay, let me see this one. Okay, you can zoom out a little bit. I mean, I can see it. Okay, so they gave you a bunch of points, and then you have to come up with the equation that represents it. Easy. So let me help you with this one. The remember, could you see one column has 0 comma negative 1? You see this? That is the what do you call it? The magic point that you're always gonna look for. So this is
Yeah.
your y-intercept. This is your b. That means you already have this ready to go. So I think we can do this one really fast, while your friends will be doing this, and it'll take some time. By the way, your friend will be using point slope. It will take a lot of time. You'll have to do it if and only if you don't have like something 0, like 0 comma something, right? This case, we already know it's going to be, well, it's plus negative 1, but I'm going to do minus 1. Is that okay? This will be like your final.
Yeah.
You follow, right? You remember? That's why I've been telling you this, man. I was like pushing you to identify your y-intercept, and we got one right at the second column. Now all you need to do is figure out the slope, and you're done. Okay, no kidding. Oh, y-intercept. Sorry, your y-intercept. You can answer right now. Let's go in it. This is your y-intercept. Put in the coordinates for y-intercept in the box. Yeah, put the parenthesis and all.
So, well, I can't put the parentheses in there.
Oh, that means they just want the y value, the b, so it's -1. Is that okay? Yeah, is that okay? Yeah. Now slope, we're gonna do the math. So the best one to pick is it doesn't really matter. It's just like 2 points. I'm gonna use the last two, m. Y1 minus y2. I'll do 5 minus 8. Tell me you understand like the y, and then I'm gonna do 2 minus 3. Do you understand? Like I'm picking the last the two columns, but you make sure your y is on top and all that, right? So this is gonna be -3 over -1. Therefore, it's 3. And that's it. This is your done. It's your equation and your slope is 3. And then write your equation, y, all of that. But do you understand how I come up with that, right? I hope you're okay, yeah?
Yeah.
Oh, wait, double check. Wait, the equation is y equals
Oh, wait.
3x, right?
Oh, bad.
-1. Delete all of that, and there you go. Is that good? Okay, let me see 21. I think 21 may be the same. Okay, 21. Okay, so write an equation of slope intercept. Well, you know how to do this one, but you have to use this one first. Does that make sense? Yeah, and then
Yeah.
solve for y. Okay, you can do that one. Let me see 22. The slope, they gave it to you. Yeah. Okay, this one you also know how to do it. Do you remember? You're going to use the m.
Yeah.
Yeah, those x1, y1, x2, y2. Solve for m. Don't forget your m formula. This is what you're going to be doing on the test, right? It'll be y1 minus y2, x1 minus
Yeah.
x2. So you'll be using this here, and then you're going to be using that. Be using this again. Oops. Then you'll be using this again, right? You think you okay?
Yeah.
Okay, let me
Yeah.
see 23. Okay, slope. Well, there's nothing to this one. You just have to look. This one is easy. They made it so that it's ready for you to use.
Yeah.
This is remember, you don't have to solve it. You don't have to actually distribute or anything. You know why? Because this is already y minus y1 equals m x minus x1, literally, right? That means your
Yeah.
slope is -2. So you can put it in if you want, -2 for the slope. They wrote it in the point slope form. But wait, what about the point on the line? Well, it's opposite this. Opposite this. You see it? Opposite the -1 and opposite the 3. So therefore, the point. You know how when you plug it in? Oh wait, I'm sorry, I'm wrong. Remember, it's y minus y1. Therefore, the y will be +1. Do you see that? It's like direct. However, the
Oh.
back here, it has to be -3. Do you understand why though? Yeah,
Yeah.
it'd be -3. Yeah, that's it. Let's go ahead and check it. There you go. I hope you're okay with that. Let me see 24. Okay. Write an equation of horizontal. Okay, this one I may have to help you here. Now, it's pretty easy, okay, but it's something that I have never worked with you, by the way, but it's very easy. We never work on these two things. A horizontal line, HOC, and vertical line, BRT. Horizontal line looks like this. The equation of that horizontal line, it's always y equals a number. I, I don't know. I'm pretty sure your teacher went over this, but we've never gone over it. And then the vertical line is always x equals a number, always. If you didn't know, you want to memorize that. A vertical line A vertical line looks like this, straight up and down. It cuts through the x-axis, whatever the x value is. Well, it could be through a point. It doesn't matter. So, but you have to know it. So it's something that I never worked with you, but you kind of want to memorize this one. I guess for the next test, horizontal line, a straight horizontal line is always y equals a number. A vertical line is always x equals a number. How do you know the difference? It just sketch one. Here's a vertical line. It will go through x. That means the x equals an equation. A horizontal looks like that, a flat line. It will go through y. Therefore, y equals an equation, equals a number. So here, let me show you the answer to this one. You plot that point, -3, 2. So -3, 2. Here it is. Okay? That means that point is -3, 2. You don't have to write it, but anyway. That means horizontal line looks like this, right? It goes through that point. That means is y equals 2. You use the y value. And then, yeah, so this is your horizontal. And vertical, it will be x equals -3. It will go through looking like that. Okay, so try to remember that one. I'll try to remember to review this with you. Okay, last one, 25. Okay, pass through that and the slope of that. I think you're okay with this one with the, point slope, right? Remember point slope? But let me double check. Write an equation of, read carefully. When you plug it in point slope, you're done. But clean up like minus. If you ever have a minus, make it a plus. You know what I mean? Well, let me do it quickly. Y equals y1 equals, this is your point slope. Yeah, that's why you want to know names too. It's not slope intercept, it's point slope. So this is a point slope. Therefore, you're allowed to just leave it. So it will look like this. Here we go. Y minus y1, which is -8. This is the only one you're going to clean up. M is -8, x minus x1, which is 3. So here's your final answer. Y plus 8 equals -8, x minus 3. You see it? You see how I got that?
Yeah.
Oh, it's plus 8, right?
Oh, wait, yeah. Wait.
So it's already in point slope form that you always use, that you plug in all the time. So you just leave it alone, but clean up the the signs where you can, like plus, minus, and all that. Wait, it's 8. Let me double check. No, you're right. I'm wrong. Yeah, it's -3, and then and x will be -3. Is that right? Double check. Yeah, looks good. You got it, dude. All right. Okay. Is that okay? You think you'll be okay doing 19, 20, 21, 22? Yeah? Yeah.
Yeah, I think we can do this.
You know why? You need to be able to do them because it's on the test. Right? Yes. So, okay. I'll let you go then. All right. I'll see you next week. Okay. Good luck.